Our community we chose was Japan because among us we know 3 people. My friend's name was Saxon, and also because 3 tectonic plates meet there: the Philippine plate, the Pacific plate, and the Eurasian plate. And these black lines represent subduction, as when one plate gets pushed under the other one like this, and it goes down. And there's also the Ring of Fire, which is in the Pacific Ocean, and there's a big tectonic plate, so volcanoes are all around it. And now we will talk about volcanic hazards.
So, we mostly did our project about volcanic ash. So as you can see, when the ash comes out of the volcano, it mostly just goes to one side. It doesn't really go to the other side of the volcano, and it just builds up like snow. And as you can see in this microscopic picture of a piece of ash, it's really knobby, and once it goes into your system, it's really irritating. So here's a picture of Sakurajima, which is a very active volcano, and here's a town called Kokushima. And so Kokushima experiences ashfall daily because Sakurajima erupts very often. So they may have posters like this around Kokushima to remind people what to do when ash comes. And now we'll talk about lahars.
So hazards, some of the hazards from volcanoes are lahars, and the ash is very toxic because, as Asha said, it can get into your system and it's very irritating. And the lahars is basically like an avalanche of ash, and that's what it looks like. And it fills up like a whole town, and it causes crop failure. And
Alright, so lahars are very dangerous, so to monitor volcanoes and tell the nearby towns about them, they monitor volcanoes. So one way to monitor volcanoes is called remote sensing, where you essentially have a satellite in the atmosphere that measures the thermal changes within the volcano, which can signify more magma rising up. This is how a altimeter works, and essentially how a volcano starts. So there's a magma chamber, and then as magma starts rising in there, it becomes more inflated, and the ground starts bulging, and the altimeter measures if the ground bulges or anything, and then eventually the stress is too much, and then it boom, but this can find signs of it happening before it actually happens, like the altimeter. Alright, and so another way is seismicity, where it measures the shaking from the volcano. Another one is gas, it measures the gas coming from it. Ground deformation, which is essentially an altimeter. And there's geophysical measurements, which is the amount, the internal structure of the volcano and what it's made of inside, which can affect how big the eruption is and stuff. So there are several agencies, international and national, in the US, all over the place, that measure volcanoes and send messages to areas around them. There are 16 decade volcanoes that are volcanoes that have a history of large volcanic eruptions, huge ones, and they live near populated areas, so they're monitored very closely for warnings and stuff.
30 seconds left to finish up on your presentation.
So for our problem, there are some unmonitored volcanoes that can cause: 1, it can damage engines from airplanes, and 2, depending on how much ash builds up into a cloud, it can also affect the climate and temperature.
And our solution is to inexpensively monitor the remote volcanoes. We would do this by having a sensor at the volcano, and it would work by placing a seismograph at the base of the volcano, and it would wirelessly tell a camera that is about 3 miles away to take pictures whenever the seismograph detects unusual seismic activity, and it would send all its data and pictures to the volcano monitoring agencies, and they can spread the warning that there's an ash cloud or some other hazard to airports or any town that happens to be nearby, so they can evacuate.
Okay. Thank you. That was excellent. Good job. So, who came up with this idea?
We all sort of we saw the list of what we can do, and we all just basically agreed on volcanoes, and then we narrowed it down to ash.
Okay.
And then with the idea of like the seismographs and the pictures, we kind of like thinking of ways to track it. So like the camera takes pictures so you can see it, and it kind of all contributed.
Great, a lot of good research. Have you researched the existing solutions that are out there for identifying ash with respect specifically to aviation, air travel?
Well, we didn't find any that was like specific to air travel, but these are the monitoring ways that we found.
Great, great.
For the solution you proposed, have you thought about how to attach this to the base of the volcano?
Well,
Are you-
the seismograph can be like as small as the gyroscope in like an iPhone. So it could just be like buried like a foot in the ground, like at the base of the volcano. So it can still detect movement.
And you're taking pictures, right?
Yeah.
How do you send the pictures to the centralized location for now?
It would connect wirelessly, like with Bluetooth or Wi-Fi, something like
So
that.
you need the cellular stations in the locations near the volcano. Have you thought about how to, or satellite?
Yeah. Well, a Wi-Fi router could also work for that.
How do you maintain energy for these transceivers?
They could be solar powered, and if the sensor is close enough to the volcano, it could also be powered by thermal energy.
So what would the next step be for you folks? It looks like you're at a point now. I think you did research, you've converged on the problem real clearly, and you have some potential solutions. It sounds like you're still in that brainstorming stage, which is fine. What would the next step be to move this forward?
Probably just like start, I guess, somewhat testing to make sure like you could actually work, and then like start introducing it to like tell some of the agencies like, oh, we have this idea, maybe you could incorporate it, and see if they would accept it or like something like that.
Are those devices made already? How would you make those? Have you think about? Is this a device already existing, or is from your idea?
Pretty much from mine.
But
Really fine.
I know that there are some cameras that can wirelessly send pictures to like phones or computers. So I know that that camera does exist. So it is possible to send it to computers and places that have computers.
Any interest in doing further work on this? Any of you kind of, did this build up any
Take the idea,
curiosity or?
build the device and do something with it?
There's a research center not far from here that does work in this area. I mentioned this to another group who is involved, interested in plates and such. It's called Lamont, Lamont Research Center. It's they're under Columbia University, and you can definitely, one of you should call them and get on the mailing list.
We actually went there.
Did you?
Yeah.
Yeah, with an
Okay.
expert on
Yeah.
volcanoes.
There
This
you
is
go.
Alex Lloyd. He studies earth and environmental sciences.
Exactly. That's great. So you're already on their list because they obviously have research fellows there that are involved.
Yeah, he taught us a lot about all the effects volcanoes can do and all about
And the
things like
hazards.
that.
And
Hazards.
he told us about like the tilt meter and other existing monitoring agencies.
And you also went to the National Weather Service for understanding the.
And we also talked to like our town's chief firefighter to see how he would like deal with these sort of problems. Like during Sandy, he told us how he dealt with that. And, like, tried to see very similar.
Yeah, the FAA, the Federal Aviation Administration, does have a means of disseminating volcanic ash to pilots today. Being a commercial pilot myself, we do get notified even if it's from a long distance of an altitude and a location, but it definitely is not what it could be, what you're describing. So there's definitely a need here. I by all means think this is a worthwhile investment of effort. Any disagreements that you guys ran into as far as what you were doing or how you were doing it?
Well, we mostly just took votes if we had any disagreements.
You voted for things to get a consensus,
But if
and that worked?
But if it was like 4-2, maybe like 2 people, and it was really close, we might explain to them what we think it might be cleared up, and sometimes disagreements were just misunderstandings. Like,
Sure.
I know I've multiple times misunderstood what people have been saying, and I really actually do agree with them, so we just try to explain it to them.
So there was no major upsets? No. Some of the other teams, they said they fought all the time, which is normal with a group. You know, there's going to be always situations where what you think might not always be the way that everybody wants to move forward, and your idea might not be the best idea. And that sometimes is very hard for us, for all of us. But that's what teamwork's all about, is listening to others, as you said, and sometimes using a vote and listening to everybody. And sometimes, our idea isn't the best, and we learn from those around us.
So what on the YouTube is the presentation, or what is the?
On the YouTube video, it's basic.
Dean Kamen, the founder of FIRST, he gave optional homework, which was to explain how FIRST has impacted you and your team. So we were one of only 2 FLL teams who submitted a video, and that's our video.
But we will also be uploading more videos. They're recording our presentation, so we'll upload this video and our other presentations to core values and robot design.
Excellent.
And some, also the YouTube channel, some instructional guides for teams that want to start, because we're a pretty, I would say, somewhat senior team. We've been doing this for a little while. And, so we would tell them how to start a team, how to mail, how to get help and all that, get a coach, start at their school, things like that.
That's wonderful. Reaching out and helping others. You obviously work very well together. You can see your chemistry. You all are participating, and you can see that you all enjoy what you're doing. Am I right? Good. Well, keep up that great work. Really good presentation. Thank you for your time.
Research.
Thank you.
Good job. We'll make some comments and feedback for you on the paperwork that you'll get later on. Have a great afternoon.
Have a nice day.
You too. Bye-bye now.
Good luck for your competition.